My dear friends, welcome to Rajshekhar classes on Applied Data Science with Python. This is lecture number 512. In this lecture, we will try to understand connected components. The next very interesting property is called a concept called weakly connected component. First, I will explain you what is a strongly connected component. First, we will learn what is strongly connected component. Then we will learn weakly connected components. We will learn why weakly connected components are important for our task. So let's go step by step. So what is strongly connected component? If you just Google search for it and go to the Wikipedia page, so there is also a nice Quora question where they use the same image given a directed graph. So what we have here, a directed graph. We have all of these vertices. What are the vertices? A, B, C, D, E, F, G, H. This is I can say, let me say, this is one subset of vertices S1, isn't it? This one is one subset of vertices. This is one subset of vertices. Yes, this is S3 is another subset of vertices. You are broken off your graph capital G. Just we are breaking this capital G graph into S1, S2, S3. You are broken off your graph capital G into subsets. The subgraphs are S1, S2 and S3. We are broken off our directed graph in such a way that within my set S1 or within my graph S1, I can go from any vertex to any other vertex. I can go to from A to B. I can in S1 I can go from A to B, isn't it? Yes. In S1 I can go from, let me take some other color here. Yes, in S1 I can go from A to B, isn't it? I can go from A to E. I can go from A to E, isn't it? I can go like this. I can go from A to E via B, isn't it? I can go from E to B, isn't it? This is E. I can go to E to B like this, isn't it? So I can go from any vertex in this subset or subgraph to any other vertex. So if you look at my set S1, my subgraph S1, I have a path from every vertex to any other vertex. Similarly, if you take S2, we can go from, just consider S2. What is S2? If you take S2, we can go from F to G and G to F. Similarly, if you take S3, I can go from any vertex to any other vertex. So each of these S1, S2 and S3 are called as strongly connected components. So the definition of strongly connected components is, it's basically the subset of vertices such that every subset of vertices within the subset of vertices, you can go from any vertex to any other vertex. Now here the question is, why did we break it into three subsets? Let's assume we break into two subsets instead of three subsets. Let's assume first subset is S1 dash and second subset is S2 dash. Now within my S2 dash, I can go from any vertex to any other vertex, but within my set S1 dash, can I go from F to B? Isn't it? Can I go from F to B? I don't have a way. I can only from G. I can go from G to F and come back from F to G, isn't it? Yes, there is no way for me to go from F to E. I cannot go from F to E, isn't it? I cannot go from F to E. I cannot go from F to E A B. So this S1 dash cannot be a strongly connected component. So what is strongly connected component? A strongly connected component is a subset of vertices such that I can go from any vertex to any other vertex in the subgraph, isn't it? If I cannot do it, then it is not a strongly connected. That's what a strongly connected component means. Now, what is weakly connected component? Now, imagine if I ignore these directions, we are simply ignoring these directions. Can I go from any vertex to any vertex? So weakly connected component is basically, it's a subset of vertices such that I can go from any vertex to any other vertex when I ignore the directions on each of these edges. So that is clearly stated. A weakly connected component is one in which all components are connected by some path ignoring directions. So this is entire graph would be a weakly, this entire graph would be a weakly connected component. Now, you might wonder, why do we care about weakly connected components in a system like this? Let's consider a graph in which I have 8 vertices. Let S1 is subgraph which is having 4 vertices, and S2 is also a subgraph which is having 4 vertices. I can say S1 is weakly connected component, S2 is also weakly connected component. Why it is weakly connected component? When I ignore the edge directions, I have a path from every vertex to every other vertex. When I have a bunch of weakly connected components, S1 will be one community of users. S1 will be one community of users, isn't it? So let me give an example. Let's assume all of my college friends belong to a community here S1. S1 could be my college friends. Let S2 be all of our work related friends. It could be forming completely different cluster of points. Here my college friends and work related friends could be completely different. Weakly connected components basically forms communities. A group of similar users or users with similar interests, or people from same college, or people from same ethnicities, or people with similar interest, people from same region could properly form one community. So weakly connected components in a graph theory can be thought of as community of people. They can be thought of as a community of people who share something similar amongst themselves. Imagine if I have an edge in between S1 and S2, just a presence of this edge, it will become single connected component, which means single community. Now imagine if you have two users, UI and UJ, that belongs to some weakly connected component. That implies that there is a very high chance that UI and UJ share something similar. Weakly connected components are useful to detect communities. Achieving that with network X is simple. Just a single line of code. Given any two vertices A comma B, it will determine belongs to same weakly connected component or not. This is going to be a binary feature, isn't it? It's a binary feature. This literally tells me two vertices A and B, tell whether they belongs to same community. Very useful and interesting feature. Very simple. You can just give two vertices and say whether they belongs to same weakly connected component or not. Just go through this lecture. If you have any difficulty, please keep a comment. In my next lecture also, I will continue this particular case study. Thank you very much.